Okay, so on to example number one. So what we're looking into here is we have an equation. We have multiple variables of x. Now they all are linear here, but we can see we have these denominators. And again, I don't really want to use my fraction operations here. So what I'm going to do is I'm going to identify the LCD, which is going to be the common denominator or the common multiple of 4, 3, and 6, which in this case is going to be 12. So I'm just going to write that in there so I remember it, or not LCM. It is the common multiple, but a lot of times just refer to it as the denominator, equals 12. Now what I'm going to do is I'm going to multiply everything by 12, okay? Now, unlike my warm-up where I kind of wrote this out like that, I'm going to save myself some time. And I'm just going to go ahead and simplify it as distributing this 12 to everything. All right, make sure it's times everything. So when I do 12 times this, you can see 12 divided by 4 divides into 12 3 times. So I'm left with 3 times x plus 1. Here I'm going to be 3 divides into 12 a 4 times. So that's going to be, a 2 minus x. And then I'm going to have 6 divides into 12 a 2 times, and then I'll just put a 1 there just for fun. All right, so now what we've done is just by multiplying everything by the common denominator, I have eliminated my fractions. So now I just have a multi-step equation, which is like Algebra 1 stuff. So I just can hopefully feel a little bit more confident. I just need to apply distributive property and then get the variables to the same side. So I'm going to apply distributive property. Okay, so therefore I get a 3x plus 3 equals an 8 minus 4x, and then plus 2. And then what I'll do is I'll add a 4x to both sides. So now I have a 7x plus 3 equals 8 plus 2, which is 10. Subtract the 3 on both sides, and I get 7x is equal to 7. Divide by 7, and x is equal to 1. Now, I don't need to check for extraneous solutions because two parts. One, I never went from a linear equation to a quadratic. Like I never created that situation where a extraneous solution could occur. And then also, none of my variables are in the denominator, right? X is always in the numerator, so I don't really need to worry about any value that I find not being in define my 0. And that becomes the same case for b. I'm not going to have to worry about extraneous solutions because there's no values here where x could not be undefined, but I still need to find the solutions. So in this case, now you can see here I have just a random number. It's not a fraction. So remember, if you're dealing with fraction operations, just write that over 1. All right. So now my denominators are 1, 3, and 4. And I guess a common theme in this one is the least common denominator is going to be 12. It's not always the case, but often 12 is a good number to have or a good number to use. So I'm going to multiply everything by 12. So in this case, I get 24 plus, let's see, it's going to be 4 times x minus 3, and then equals a 3 times x. Okay, so again, now I just have a multi-step equation, apply my operations, and then get the variables to the same side. So I have 24 plus 4x minus 12 is equal to 3x. I can combine my terms here. So 24 minus 12 is just going to be a 12 plus 4x equals 3x. And then what I'll do in this case is I'm just going to, let's just subtract the 4x. So therefore I have a 12 equals a negative x, divide by negative 1, divide by negative 1, x is equal to a negative 12. Okay, so there we go, all good. So now let's get into some problems where we have some denominators that are not as fun and easy and simple as just using the number 12, right, for our common denominator. So in this case, this kind of comes into, though, like what is the common, like, again, a lot of times we get the common denominator, 3 and 4 by multiplying them, right? 3 times 4 is 12. However, we didn't get 12 was not the common denominator of the product of 4 times 3 times 12. So you want to be careful. You want to find the smallest denominator that they all divide into. And a lot of times that is going to be the product of your denominators. But the main thing we want to do here is simplify, okay? So whenever you're looking at your denominators, if you have an opportunity to factor them, then first step you want to do is factor them. So I see this 2x minus 2. I'm going to want to factor this into a 2 times x minus 1. All right? Now, when we're dealing with a polynomial as like my denominator, or at least an algebraic expression my denominator, it's not as easy to understand like the multiples of that. Like the multiples of 4, are rather easy. 4, 8, 12, 16, 20. But the multiples of x minus 1 are not as easy to like spot off. Like what does x minus 1 divide into? Well, we remember from our divisions of polynomials, we can divide expressions, right? We can divide a polynomial into another polynomial. But a lot of times what that comes into is if I have a polynomial, if I multiply it by anything else, then I know that that polynomial divides into that product. So the easiest version of typically what to do here is usually to multiply your denominator. So I see here I have 2 times x minus 1. I have a 2 and an x minus 1. So my common denominator here is just going to be the product of 2 and x minus 1. And again, you can check your work. Does 2 divide into this? Yes. Does x minus 1 divide into that? Yes. And you could use long division, whatever, like to check that out. And you'd see that each and every one, they evenly divide into that expression. So now I'm going to multiply everything times 2x minus 1. Okay. And what's cool about this is, again, this is our ideal of getting rid of our fractions, getting the x off the denominator. So if I do this and I still have x's in the denominator, I didn't multiply by the LCD or I made a mistake. So what you notice is when I multiply 2x minus 1, which is really like over 1, when I multiply that over here, I have this, I have, that's an extra parentheses. Let me just rewrite that. Rewrite that purple. There you go. So when I multiply 2x minus 1 over 1 times this expression, the 2x minus 1's divide to 1. So therefore, I'm just left with a 3. Really a 3 times 1, but, it's really 3 times 1, but we can just write 3. Over here, when I multiply it times this term, you can see the 2's are going to divide to 1. So I'm left really just the 1 times x minus 1. And then over here, you can see when I multiply that times this terms, the x minus 1 and the x minus 1's will divide out. So I'm left with the 2 times 2, which is equal to 4. And I know it might be a little confusing here because this is kind of like written down lower. So hopefully in my other examples, we'll kind of see. But I didn't want to rewrite this broken out for each and every one because it takes a little time.
Good afternoon, students. If you are on campus and unsupervised, you should be at the front of the building waiting for your ride. No one should be in any little cubby holes. Please make sure you are at the front of the building waiting on your ride. Thank you.
Okay, so back to the video. So now in this one, I can just set 3 plus x minus 1 is equal to 4. And now I'm just going to basically solve for x. X is equal, let's combine these. So this would be x plus 2 is equal to 4. And then just subtract it 2. Okay, now this might have been a little confusing, so I'm actually going to work this one out. Okay, I'll do the exact same thing, but I'm just going to like show you a little bit how they divide out because I know that might have been a little confusing for some of you. So in this one, again, I see something that's factorable, which is x minus 1 times x plus 1. So again, what we can identify here is my LCD is going to be just the product, right? Because does x plus 1 divide into that? Yes. Does x minus 1 divide into that? Yes. So my LCD is x minus 1 times x plus 1. So what I'm going to do is I'm going to multiply everything times the LCD, x minus 1 times x plus 1. So I'm actually going to write this one out, as I mentioned. So let's actually write that out. So it's going to be x minus 1 times x plus 1 times 2 over x plus 1 minus x minus 1 times x plus 1 over 1 over x minus 1 is equal to 2x, let's do it one more time, x minus 1 times x plus 1 times a 2x over x minus 1, x plus 1. See, running just out of some space here, but I had enough. And that's basically the operation I did here. I applied distributed property here. I just didn't show my work. So now I'm showing all my work. And what you can see here is the x plus 1's divide out. One's in the numerator, one's in the denominator. They divide to 1, right? These are in the numerator. right? That's why I put that over 1. Those are in the numerator. Here, the x minus 1s divide out, and here, both the x minus 1s and the x plus 1s divide out. So now what I'm left here is I don't have any more denominators. All my denominators divided out. So now I'm just left with a 2 times an x minus 1. Be careful with this negative. That's going to be a negative x plus 1 times 1, so I'll just leave it there, is equal to, the only thing left is just a 2x. So you can see by identifying my least common denominator, multiplying everything by, I no longer have my denominators. Now, I just got to be careful with subtraction though, okay? Make sure you're keeping those parentheses, because if you don't keep those parentheses, then it's just minus x plus 1. Now I'm going to apply distributive property here, and therefore I have 2x minus 2 minus x minus 1 equals a 2x. Now I can combine my like terms and get them to the same side. So here I have a x, negative 2 minus 1 is a minus 3 equals a 2x. I'll subtract the x. And you can see I get a negative 3 is equal to x, or x is equal to 3. But now, oops, I did forget to kind of check this. Now, I never changed this from a linear to a quadratic, but we should always check our answer. So if I take, because we could have a possibility of an extraneous here in the denominator, but when I plug in 3 into all of these denominators, I'm never going to get 0, right? 3 plus 1 is 4, 3 minus 1 is 2, 3 squared minus 1 is 8. So we're good. In the same respect, for the other equation, which I kind of forgot to do, if you plug 2 into your denominator, you're not going to get 0. So that equation as well. That equation is good as well. Okay, so now let's go ahead and get on to the next set of 4 problems.